My on-track camera shots suck a little bit, and I'm gonna fix that today by making this really cool 3D printed bracket. I'm gonna show you how I made it, and I'm gonna show you how you can make it also. So in order to get the most interesting shot while we're on track, we're gonna go ahead and try to find somewhere where we can mount the camera in a kind of rear-facing orientation on the bike. So I mentioned before in some other videos that I'm a mechanical engineer, which means that I get to play with a lot of cool stuff on a regular basis. And one of the cool things that I get to play with a lot are 3D scanners. And so this is actually a consumer 3D scanner by a company called Einstar. So this is the Einstar Vega, and the cool thing about this scanner is that this is the whole scanner. There's no kind of handheld thing that connects to a laptop and whatever, because those things are just a pain in the ass to take with you. They're not mobile. This is the whole thing. This is all there is to it. So it's the screen and the scanner all in one, which means I can take this thing with me anywhere I want to go. But yeah, so I'm going to use this thing right now to scan this bracket, and that's going to form the basis for the mount that I'm going to make. So all that I've really done to prepare this bracket is I put these kind of reflective little dots on there. And you don't really need to do that, but it just helps the scanner see it a little more easily. The other thing you can do too is they make this like kind of reflective spray that you spray it on there, and then after like 4 hours it evaporates off. And again, that makes it a little bit easier for the scanner to see the part. And especially with these kind of consumer grade scanners, it helps a lot. The real commercial ones, they don't really need it as much, but for this one, it helps. All right, so we're gonna scan this bracket now. I'm gonna use this 3D scanner because I'm lazy and because I have it, but you don't actually need that. You can, you can use hand tools to measure this. There's a number of different ways that you could potentially get some of these geometries and shapes in order to put them into a CAD program. But we're gonna use the scanner. All right, so that's really all the data that we need. So now we have the scan data. I'm gonna go ahead and mesh this and then clean it up a little bit in the software that comes with this scanner, and then I'm gonna import it into CAD, and then we're gonna start making our bracket. All right, so now that we have our scans, we're gonna go ahead and import them into the computer, and then we're going to do some cleaning up, and then output a final model that we use as the base for our 3D printed part. So now I have cleaned up my part in the scanner software, and I've imported it over into SolidWorks. So I know what a lot of you guys are thinking. I don't have SolidWorks. I can't afford SolidWorks. That's a professional grade CAD software. How do I do that? Actually, you'd be surprised. It's probably not as expensive as you think. This is SolidWorks Maker Edition. So this is $24 a year for a license. And so you can save all your parts on the cloud. You can save them locally on your computer. You can create as many parts as you want. There's no limit like some of the other softwares. And it's designed for people who want to do home 3D printing, people that want to do home machining, or if you don't have access to either of those types of machines, you can actually still make parts and then send them out to services that will machine or print the parts for you. So, you know, like I said, It's really not that expensive. Pretty much anybody can pick it up and learn it. There's plenty of tutorials out there to learn how to do it. And so, yeah, go ahead and try it. All right, so this is the part that we imported from our scanning software into SolidWorks. I was able to click on these two surfaces, this surface and this surface, and then there's a function in SolidWorks that it basically says find this surface and make CAD surface out of it, and that way I can use it as a datum to do my modeling from. That's what I've done, which is what you can kind of see, this like solid gray portion. That's where it's put that surface in there. And so what I'm going to do now is I'm going to turn on the parts for the actual bracket so you can see those. And then I'm going to make one of them, I'm going to make this front one transparent. There we go. So now you can kind of see what's going on with this, right? So basically what we've done is we have taken the geometry from this bracket, this hole here. I've created kind of a plug that goes in there and that helps align everything. And then we've created 4 bolt holes that our bolts are going to go through. And we made sure to countersink these so that way the bolt head is not sticking out through the part. What I really don't want is I don't want that bolt head snagging my pants or my suit or anything like that if my leg accidentally somehow goes back that direction. And so I countersunk those on here, and then the same is true on the back side. So you can see that there's these countersunk holes, and these are in the shape of the nut so that the nut sits flush below the surface, and B, also so that the nut won't spin when I'm trying to put everything all together. So this part right here is just a standard geometry for a GoPro mount, and so you can actually find this pretty easily on the internet. It's not that hard to find the dimensions for it, and so you can just copy those dimensions and put them into your part. And so you can see on the bottom side here there is again, it's countersunk for nut, and the nut that I use are the same ones that GoPro uses. They call them acorn nuts, and they have kind of a rounded dome, and that just makes it to where you don't have that screw sticking out, again, to help prevent you from getting your pants caught on it or anything like that, just to make it a nice smooth surface. And so this part is basically lined up vertical. This bracket kind of sits a little bit at an angle on the bike, and so you can see I just basically lined this bracket up with this part right here, made them in line so that this part is vertical, so your camera is nice and vertical. And then that's pretty much it. I'm gonna make this first part transparent so you can see kind of what's going on in the center here. All right, so like I said, there's that plug, so you can see that there is a recess on this part right here, and that plug kind of goes into that, and that helps everything go together real nicely. You'll also notice that these parts don't completely touch. There is a space between the bracket and the part on both sides. And the reason why I did that is because I'm actually going to put a little stick-on rubber piece between each side of the bracket. What I'm trying to accomplish is A, I want to reduce some of the vibrations going into the camera, and B, I also want to prevent that plastic piece from rubbing on that exhaust bracket, because I don't want it to take the paint off the exhaust bracket. I don't want to damage the bike in any way by adding this. So that little space gives me just enough room to put that little rubber piece in there, and I'll show you what I'm talking about here in a minute. All right, so I've taken the two pieces that I created in SolidWorks and I've imported them into the slicing software for my 3D printer. I have a Bamboo Labs 3D printer, but most 3D printers are going to come with their own slicing software. You take the file in SolidWorks, you convert it to a STL file. It's a stereolithography file, and then just send that straight into the slicer. And so I've already gone through and configured all of the sizes for all of the different types of filament and everything else that are in the printer, and I've already kind of done that for different projects. One of the big things that you'll probably have to do for each individual project is adjust these supports. And so you can see the supports down here, right? So these are the supports for the project these are real thin little walls, and so they're just going to break right off. It's super easy to get this part out afterwards and then just break everything off. And you can see there's not a whole lot of supports on this side, but on the bottom side there are some supports in here, and again they just kind of break right off. So it's pretty easy to get this thing off and get it all cleaned up. Nowadays it's a lot easier than it used to be. So now the next thing you can do from here is just send this to the printer. You just literally hit print plate. And so this Bamboo Labs printer I think is really cool because this is set up wirelessly. I'm downstairs, my printer's upstairs, and so I can actually just hit print and it will send this to the printer wirelessly. The printer will go ahead and start, and I can even click on this preview window right here and you'll see that this shows me exactly what's happening in the printer. So if I were to hit print right now, I could see this thing as it prints, and so I don't even have to be in the same building as this printer. I'm a pretty big fan of the Bamboo printers so far. I've only had this one for a couple months, but so far it's been incredibly impressive. And again, I'll leave a link to this in the description if you guys are interested in this printer. All right, guys, so the next thing that we're going to do now that we've gone through all that is just print the part. All right, well, the last thing to do is to break off all the support material. All right, well, there you go. That's half of our finished part. To actually install the camera, you just, on the GoPro style cameras, just fold those legs out if your camera has those. And then just align it with the tabs like you would any other normal GoPro. Drop the screw. Stick that screw through there, and then on the bottom side there is a retention slot for this fastener on the other side, and then just kind of aim it in the right direction and tighten it down. If you're actually taking this thing on track or for a long ride or something like that, I would recommend you probably use something like Loctite or something like that, because there's a lot of vibration. And so the last thing you want is for this thing to vibrate loose and A, the expensive camera fall off, or B, it somehow get stuck in any of this assembly or anything like that, and then you could have problems. So yeah, like I said, if I were going to use this for track day or something like that, I'd probably Loctite it. I'll put this geometry on GrabCAD and some of the other websites that you can download STL files and stuff for 3D printing. I'll probably put it on Bamboo Labs on their app as well, and so anybody that wants it can just come and download it. If you don't have a 3D printer, there's a couple options. You can either send it out to be 3D printed at places like Xometry, or there's some other places that'll do 3D printing. Or if you're interested, you can just hit me up and I will print it as well. And so what I ultimately am going to do is I'm going to take my 3D scanner with me to the track. And so the goal is anybody that wants a free 3D printed mount to mount their GoPros on their bike, just hit me up at the track, and then I'll scan your bike, make the part, and then ship it to you. And then what I'll do from that is I'll just take the CAD files, keep them, and anybody that wants a mount after that I have the design for, I'll just sell that online. So if you want a free one, hit me up at the track and you'll be kind of the test dummy. That's the deal. I'll leave a list of all the hardware that you'll need for this in the description of the video. And this is kind of the first prototype. I have some ideas for how we can make it better. Things we can do to make it simpler, make it easier to print, and then help reduce some of the vibrations that you can see in the video. And so, yeah, we'll kind of, we'll optimize from here. So cool. All right, guys. As usual, have fun, ride safe. Don't f it up. All right. I'm going to go for a ride.